so it's 3:45 on a Tuesday. You've been sitting through at least 4 hours worth of talks, and now I'm going to talk about data architecture. Can we get through this? We're going to try. I'm going to try to make it as exciting and interesting as possible. So I'm going to talk about how to build a data strategy in 2016. And just for reference, can I get a show of hands of how many developers are in the audience? All right, how about non-developers? Okay, so cool. This talk is for everybody because everybody works with data in at least some scope, either as a developer, as an analyst, or as a decision maker. So this talk is about how everybody can benefit from making a better data process. So just a quick plug for my company. I work for CapTech. We're based out of King of Prussia, headquartered in Richmond. We do consulting. We build apps. We do UX, UI. We do data, and we do agile. So if you're interested in working for us or working with us, come talk to me. A quick note about me. This sticker is the same one that's on my laptop, and it basically means I've been through almost all of the data ecosystem tools. I've been through everything from Excel up to Hadoop. Right now I work as a data scientist, working with Python and R, and I prefer Python, but that's just a little bit of my bias. But I've worked across a number of different companies, a number of different industries, so I have a little bit of insight into how data practices work across the scope of the tech spectrum. Enough about me, enough about that. Let's talk about the data landscape. If you were working in data 10 years ago, this was your tech stack. Right, so I remember I started out with SAS, and it was like a SAS instance that was not a real SAS instance. It was underground, so I had to connect to some Unix terminal, and I had to import all my data into SAS commands, and that was essentially where you were as either an analyst or an engineer at that point, and then you had a big enterprise database, and then of course everything got exported to Excel. Around that time, everything also really changed with this thing that you can't see here, which says, ironically, big table, which is when Google got too big for a single server, and they essentially said, let's have our database on multiple servers, and let's build a whole infrastructure around that. So in my opinion, the whole big data movement really started around there, and a lot of the big data technologies that we have today are based on that. So this was the landscape in 2006. What does it look like today? Oh my goodness! This is crazy. So this is a survey that these two guys, Matt Turk and Jim Howe, do every year of the data landscape as it exists in 2012. And I see some of you squinting, and that's the point. Like, this is nuts. You can't really see some of this stuff. And that's because there are over 500 companies offering different data products on here. This market is now $125 billion. And everybody now wants to do a data project. I was reading a Gartner survey where 75% of managers want to do some kind of data project within the next 2 years. And the same survey also said that 50% of data projects will fail, no matter what kind you have. So this talk is kind of aimed at preventing that. So what caused this? Obviously, the rise of commodity hardware, the Internet of Things where we can track more stuff, and then web tracking where we can keep it and capture it. So now we have this. So the talk is really about what to do with this. When you have so many choices, so many options to choose your infrastructure, there's a lot of potential for really cool data projects, and there's also a lot of potential for failure. So now that we have all this cool stuff, how do we actually end up use it? How do we pick a stack? So I'm going to talk about three things. First, I'm going to talk about the basic roles of data or data heuristics that you yourself as an individual can think about when picking something or when coming into a stack. The second is picking the right tool for your data team to discuss amongst yourselves. And the third is what kind of industry benchmarks already exist or what kind of precedents there are for this kind of process. So first, let's talk about the basic rules of data. The first is the second rule of thermodynamics, actually. If you're familiar with that, it's the law of entropy, and it says that everything will go crazy if you let it. Basically, everything can devolve into chaos, and I see most of you are software developers, so you're probably well familiar with that theory. Basically, the more things you add to a project, the more complicated it gets, because there's more potential points for interaction. So let's say you start into an analytics project, and you have a simple goal. I want to know how many customers you have. The first part of this is actually defining what it means by customers. And this has been a question in every single project that I mean. How do you count customers? Is it active customers? What is an active customer? Is it someone who's used the product in the last 10 days, in the last 10 seconds? Is it someone who's paid? Is it someone who hasn't paid? What if you have two people, like a family, a household on a Netflix account? Is that a single customer or is that two customers? So you have that level of business logic. And then you go with that level of business logic to your architecture. And you say, okay, well, maybe I'm a small software as a service provider. I have a couple sources of data that I just want to look at. I have these Apache weblogs. I should have a billing system where I can see that customer data. And then maybe I have a CRM where I look at potential and current customer relationships. And you think, okay, I'm just going to shove it into the source of truth, and I can just query it and find out everything that's going on here. That's usually how the project starts out. But the problem is, what if your Apache weblogs aren't the same as your billing data? What if these two things don't talk together? So then you have to start cobbling them together, which brings me to my rule 1A, which is my own personal rule of data. The further away that the source of your data is from where you're trying to get the answer out of, the more annoying it gets to query and manage. And really, that's kind of the whole of that map that I was showing there with the 500 companies. They all do this. They're either moving data from the source to the analytics, they're conducting the analytics, or they're showing you the analytics. So when you think about picking data projects and pipelines, you really want to think of it in one of three stacks to simplify it. But the further this is away from this and away from the person that actually wants to see this, the worse it is and the more potential for complication this is. And I have a case study that I read about maybe a couple months ago. So this is Airbnb's data infrastructure. This is a really interesting blog post. I have it up on my Twitter as a part of this slide if you want to read about it. This is actually how they redesigned their architecture. And so here on the left, you see the MySQL dumps. And my hunch is, like, in the very beginning, when they were a small website, they probably just had MySQL. And then they had some reporting tool, or maybe some middleware processing it, and some reporting tool hooked up to it. And that was it. But as they grew, rightly or wrongly, they decided to add a Hadoop cluster, which is this part, and also a Spark cluster, which I'm not sure if is part of their Hadoop cluster or separate or not. But as soon as you start adding components, you start having to monitor each component and making sure that the data transferring from component to component is the same. So they have two sources. So these two have to be ingested. Here they use Kafka and Scoop. These two have to be monitored. Kafka and Scoop have to be monitored. Then they have two clusters. One is like the gold, the source of truth cluster, they call it. Then they have another one that data is being replicated to. And then finally, their visualization is in Tableau through a third cluster, a Presto cluster. So if you think about, let's say you're a manager and you want to know how many people booked an Airbnb in the past month, this is all the path that your data has to go through. And so it gets complicated really fast as soon as you start adding more tools. And then they wrote in their blog post, basically it started to become complicated, and the sources of truth, which are here, were obfuscated by how many transformations they went through in the system. So moral of the story is be really careful about what tools you want to add, and think carefully, because each one tool that you add, so for example, like let's say they added Scoop first, or Kafka, you have to monitor it through the Airflow scheduling then. So that's going to add another tool on top of that. Which brings me to the second rule, is you can simplify all of this with the Pareto rule. If you're not familiar with the Pareto rule, it's a really basic one of all data analysis. It says that 80% of something's use comes from 20%. And this is going to make a little more sense when I explain it. The way I interpreted it is, for tooling, people use 20% of their tools 80% of the time. And if you think about the software tools you use, you probably have a couple that you use a lot, like you really hit them heavily. Either it's Sublime or Unix or whatever, you really love those tools. And then there's a couple where you're like, oh, I don't want to touch them. And this is true for non-technical stuff as well. So this, again, comes up in data work as well. So there was this survey in 2015 done by O'Reilly of data scientists and basically how they work and all their habits. And I think it was like something like 10,000 data scientists that they surveyed. And they basically asked, what language do you like to work in? When you think of a data scientist, you think of them doing like cool AI, sexy stuff. And if you look here, SQL takes up 70%. 70% of data scientists prefer to work in SQL or choose that as one of their primary languages. And Excel comes up with 60%. And then the third one is Python, and then R and MySQL, which is cheating because it's really just SQL. So this is, if you think about it, O'Reilly surveyed like the top people in the industry, people who work in Silicon Valley, people who work everywhere, and this is what they chose. And this came up in this blog post too. I linked to it about the emergence of Spark, which is like the new hotness in data science right now. If you look, so there are a couple of APIs into it. There's Python, Scala, there's kind of Java, and then there's also SQL. What do people like to use the most? SQL, because it's known, it's standard, it's been around for 30 years, and it's easy to write. So when you think about the tools that you're picking for your team, think about the tools you already use. If you're happy with some of them, use those and pick those, especially if it's SQL. And this brings me to my third rule from a team level as opposed to an individual level, which is Conways Law. And Conways Law says that organizations design systems in the way that conflates with the structure of those organizations. So however the top of that organization wants to see that data is how that system will be designed and how it's best to be designed. So my example for this is 18F. If you haven't heard of it, it's an agency within the federal government that's more agile and designed to deliver services in a better way to other parts of the government. And they're basically like, they're very hip to standard industry practices, like they use GitHub, version control, all of that stuff. But they have two ways that they display the results of their products. So first, one of their customers is like basic citizens of the United States, who are not going to understand some of this maybe, but they will understand how many products they've launched and how many they have coming through the pipeline. So they display stuff this way in the dashboard, and then if you're a developer working with them, you're also their customer, so they have a full GitHub repo of everything, and they actually are so into it that like they do all their writing of their notes in GitHub. So it's not just developers using this, but they also do like pull requests on government orders and stuff. So I thought that was pretty cool. So the thing with this is just be cognizant of who is actually going to use whatever pipeline you end up building. Because, for example, it could be a developer, in which case you're going to want to have the code available and you're going to want to have version control. But it could be like your CEO who needs this data. And that's really what this is all about, right? Building pipelines that actually drive some kind of actionable result. And if it's your CEO and he or she is always on the iPad, then this isn't going to cut it. And looking at code isn't going to do it. And sending like maybe spreadsheets via email isn't going to do it. You're going to have it in a format where they can access it all the time, because that's going to be the value of the pipeline. So, okay. So how do you evaluate now these data tools as a team? So you have a couple of heuristics that you can use on your own to think about how you want to personally pick tools. If you have a team, how do you evaluate them? And the first one is the question of big data, right? This is what's going on today. Everybody wants to know what's big data, what's NoSQL, how do I use it, how do I not use it? So the first question is, do you even have enough data for big data? And this tweet says, if you can't read it, consulting service, you bring your big data problems to me, I say your data fits in RAM, you pay me $10,000 for saving you $500,000. So there's also this website that this inspired called yourdatafitsinram.com. And if you haven't seen this, I like to pull it out every once in a while. Maybe it'll work, maybe it won't. Basically, it is yourdatafitsinram.com. And if you put in something like terabytes or megabytes or whatever, it'll compare it against the bigger size of the single available server. And it'll say you don't need big data, which is the whole point. So that's the first thing, because because you might not need the overhead of a big data or NoSQL system to begin with, even though this is where the industry is really trying to push you. Especially if you read industry publications, it seems like everybody is doing big data, everybody is doing this and that. But if anything, I actually try to see if I can discourage people from it first, especially if you're a small business and you have something less than even, I don't know, like if you have less than 100 gigs a day that you're processing, you don't need anything. You don't need Hadoop, you don't need Cassandra, you don't need any of that. You can process all of that in MySQL or Postgres. And I think I read, like as late as 2011, Reddit, the site that has 1 billion or so visitors, had 2 tables, like literally 2 database tables. So you could probably make it work. And in fact, the last 2 projects I've worked on, I've done entirely in memory on my computer without needing to spin up any clusters. And computers are really powerful these days. And in fact, if you Google like working with big data in Python or something, you can work to up to maybe like 10 gigs comfortably in memory. So again, so if you don't need big data, then your stack is whatever you're already using. In this case, I have like Postgres to Python to Excel or whatever. But the point is, remember the first law, don't make it complicated. If you have something that already works, keep it working. The second question is what kind of data you have. And this tweet says the amount of data is growing exponentially, but the amount of clean data isn't growing. So the basic point is all data is messy. There are different kinds of messy data. It's important to figure out what kind you have and what tool it's right for. So the first thing is slow and fast data. Do you have fast data? Fast data would be something like stock trading, where you need to know in milliseconds what happens, and you need to be able to process that event immediately. If you are in something like the home insurance industry, which changes maybe every once, like how often have you changed your home insurance if you have a house, right? That changes once every 5 years or not. You don't need to be real time. And so that's the point. Like if you're stock trading, you probably need to be real time. You need to be doing Spark. You need to be doing all of this. If you're doing home insurance, you just need batch processing. And so keep it simple. The second rule of this is relational and non-relational. Again, if you have data that's highly logical, like banking transactions that need to be in the specific order, that need to be in the specific format, keep it simple and stay with transactional databases. If you're Wikipedia, or if you have a comment section or something that's non-relational, then you want to consider something like Mongo or HBase, possibly. And the third thing is, do you have special data? It's possible you do have special data where you need a really complicated system made up of some of those components that I showed in that slide with 500 companies. If you're doing anything with like astrophysics processing, if you're doing anything with genetics, if you're doing anything with social networks like Facebook, then you probably do have special data and you really do want your own stack. But most of the time, that's not the case. And the third thing is to think about who's going to be working with your data. Not only who your end stakeholder is, who's actually going to be making the decisions that this data is based on, but who is actually going to working with this. So this says basically, how do I query the database? And it says you write a distributed MapReduce function in Erlang. So this is great for developers. And if engineers are going to be querying the data, you want to think about the product you're picking and like what kind of documentation it has. Does it have support? Does it have APIs where you can join it to other projects? Can it be tested? Can it work with other projects that your company has? If it's going to be analysts or data scientists that are working with this, you want to think about what kind of access can it give them? Can they accidentally delete the production database somehow? Do they have to write distributed MapReduce functions in Erlang, or can they just use SQL or something? And how can they trace where this data came from? And if it's going to be decision makers, what is the meaning of the data? Like, how do we provide context around it? What tool can give us that? And also, how can they change the views of the tool, basically? And how can they talk to the engineers that wrote this stuff? So with that, there's a couple of common architecture patterns that I see today, just from my own personal experience in reading what's going on online. And again, you'll notice the Pareto rule is in play here, because 80% of it is this, and 20% is this. So surprisingly, I see a lot of companies, especially small businesses, which there are a lot of, which are fine with this kind of stack. You have some sort of database, you process the data somehow, be it in Python or R, and you spit it out to some sort of interface, either Excel or Tableau or something else. And this is surprisingly common. And then you have 50%, which are operating in the standard relational world. Larger companies, Fortune 500 companies, which have a database instance, which is then hooked up to like a Java web app, or which is then displayed in JavaScript, or also takes Google Analytics. That's a pretty common flow too. And then you have this 20% that you're always reading about in the media that are doing very interesting, very new, interesting stuff. And these are the special cases that I talked about earlier. So what I'm saying is 80% of the time you probably, depending on how you evaluate everything, don't even need this. So you could have something like Kafka feeding into Spark on Hadoop, and then feeding onto a Tableau server. So this happens about 20% of the time. So what I'm saying is reduce that chart by about 80%, and you'll have your possible patterns for architecture choices. And then I just have one more slide of interest that could be of new data trends if you're interested in like what the latest is. So again, Kafka is huge if you do have big data. Feather is the new top-level Apache project that's supposed to bridge like Hadoop and your computer in memory, especially, and it also bridges Python and R a little better. For analysis, there's obviously TensorFlow, which everyone is talking about. I haven't read a case where it's implemented in production yet, except for at Google. And then there's also this Bayesian query language project, which is like SQL, only for statistics. And then for visualization, there's Jupyter dashboards and Caravel. And I just included these as references for links of like what's coming next and next. But again, I hope you got that the point of my presentation was that you don't necessarily always need these. And when you make choices, that you can eliminate most of this stuff in favor of the tools that work for your team to get results from your data. So that's all I had. Thank you. Hopefully that was nice. If you're interested in more, I wrote a post about it, linked here. It's on my Twitter. Do we have time for questions? Yep.
You might go back to the slide of the 3 stacks.
Yep.
So for some measurement of hard, how much harder is it to do the last one with the interesting, crazy data, or crazy systems, so to speak, or interesting data, versus the top one that you said is most common?
I think it depends on how much data you have. Because if you don't have a lot, you could theoretically get the third one set up and running and just process it. But then once you get past a certain size of data, when you actually need this, you need certain rules about like how often you want to process this data. But I would say it is a lot of overhead, like to get the third part set up, and oftentimes you'll need a special administrator or developer to run this stack, which is where a lot of the overhead comes in as well.
So it's not necessarily the stack itself, it's data processing.
I think it's a little bit of both, but I would say like as you get more data, it becomes harder too. Yep.
Well, in your opinion, at what point do you stop looking at pre-built analytics solutions versus like building your own? When should that inflection point be with regards to cost or size of users and stuff?
Are you talking about like display analytics solutions or pipelines or?
Both.
I'm going to give a consulting answer if it depends. But I think like my thing is if I've fiddled around with something for like 2 weeks and I can't, well, depending on what part of the stack, and I just can't get it to work, then I want to move to something pre-built. But my hunch is I always check what's already out there because I'm almost sure that somebody's built a solution to my exact problem. So I'll start there first, and then I'll try to move on to what I've tried to build myself. Anyone else? Yep.
Where do we get this slide?
It's on my Twitter. So my Twitter is @Boykis, and I just posted it there. Anyone else? Okay, hopefully it's time for coffee.